My name is Narasimha Krishnakumar. I'm a product line manager here at VMware. I'm joined by Sunil Satnur, who is a staff engineer in performance. He helped us create some of the slides, so I wanted to acknowledge him. And if you have any performance-related questions, you can feel free to address it to him. And then I'm joined by Lebin Cheng, who is a group product line manager at VMware, and we'll be walking you through what's new in View 5.1 and what's next. With that, I'll hand over to Lebin. Lebin.
Thank you. Can everybody hear me? Great. Welcome to VMworld 2012. As you are familiar with, everything has to start with disclaimer. And some technical difficulty.
Yeah.
So in every VMworld I went to, there has to be a what's new and what's next for View. So this is it. And this is likely to be your first sessions you go to. So I'm glad I will be here, present to you. I think I see a lot of familiar face down there. And I will be the what's new guy. And the what's next will be Narasimha. The second half of this show will show you what's coming, what's exciting, coming down the pipe. Since this is going to be your first sessions, breakout session at least, so I want to start it out on a light note. Let's take a little bit of a historical quiz, if you will. And you don't have to come to the mic to answer the question, just shout it out. So keep some, so if you're sitting in front, you have strategic advantages. And we do have gifts. This is a bag of gifts here. Come claim it. So how many of you, show of hands, how many of you come to VMworld 2011 in Vegas? Wow, welcome back. So now here's the quiz. This is.
You probably need to stand here.
Yeah, probably need to stand here.
Let's switch positions.
Who remember this guy?
Cool. Should I throw him a gift?
So, sure, yeah. This is Victoria, our VP of Marketing. You still remember him?
Sorry.
So do you remember the View 5 t-shirts, the View 5 video? Who can sing? Come here to sing the song. You will take the whole bag. View 5 in the house tonight? So now here's the real one, to be serious. Do you remember what is the biggest product feature we advertise in View 5? What is the problem we solve? Accelerator, the end user experience. Bingo. Only one guy taking that question?
You get one.
I think we need to do better than just the video and song.
Walk to you and give you a gift.
And yes, it is. It is the end user experience. We think we addressed the end user experience heads-on in the past year, View 5, and we continue to do so. However, with end user experience addressed, with the end user no longer seeing VDI as the end user experience that bring to it as being the issues, increasingly we are seeing total cost of ownership being the top of mind issue. So just a quick show of hands, how many of you think total cost of ownership is among your top 3, top 5 issues?
Okay.
Great, so
almost
at
50%.
least 70%.
Yeah, almost 50% to 70%.
And we hear you, and that's why we continue to work on features and also product solutions to address the total cost of ownership. Some of you may nitpick us to say, hey, that's a minor side. No, that means total cost of ownership consists of 2 parts, CapEx and OpEx. And we make great improvement in both fronts. And as we release View 5.1, which we did in May this year, we have significant improvements in the product, addressing both OpEx, the manageability of the product, as well as CapEx, especially in the storage cost part, the infrastructure cost. So in the remainder of this presentation, I'm going to cover the OpEx part in View 5.1, what's new in View 5.1, and some of the continued improvement we make in end user experience. Then we strategically position the important part, the fun part, to the second half of the show so that you stay with us and you don't pick the gift and leave, to talk about the exciting new features coming from the platform, how View take advantage of some of those to address head-on the CapEx part. the storage cost specifically. So with that, let's move on. So if I want to, excuse me. So as you can see, these three areas actually we just touch upon them. Storage accelerator, addressing the storage cost, storage performance, and the manageability, especially at scale. We are starting to see large-scale view deployment. This is a good problem to have for us. We are having admins coming to us and say, your product is very easy to implement, very easy to manage at smaller scale, but now I need to at larger scale, at 10,000 or even beyond. And small things that is easy at small scale become difficult when the deployment becomes large. So we pay attention to that, and we actually implement features to help that. And we will continue to do so. And we didn't stop improving end-user experience. We addressed the issue heads-on in View 5.0 last year, but we didn't stop the work there. So there's even more end-user experience enhancement in View 5.1. So let's talk about some of the manageability features. And this is just as you deploy more and more to more users. We are seeing, it's a shameless plug here, John Doss and myself are going to have another breakout session specifically focused on how you can manage a large-scale deployment. But just a quick report, by 5.1 time, by the beginning of this year, we are deploying at large scale, as large as 50,000 seats. And in those kind of environment, small things such as admin UI performance, such as the log size, the event log size, and whether or not you can just log it to syslog, use plain file to store the log rather than having a huge database, or being able to install View Composer in a standalone server so that you don't have to have a one-to-one relationship matching the View Composer to the vCenter server itself. Those things starting to become important to admins. So I'm happy to report we address all that, and we wrap it all up in a best practice solutions that we can guide our administrator as they expand the View deployment from proof of concept to small scale and to larger scale, to the tens of thousands. And on top of that, we are seeing customers being more and more diverse as well. It's very natural. As you scale, not only small customer expand the number of seats, but as well, we also expanding into different kinds of segments of the customer. So in order to help the product management group, the product marketing group, to focus, to invest in features that matter most to you, we implement what we internally call the foam home feature, which is an opt-in feature. If your situation allows, you can please enable this when you install 5.1. That can only help us understand your environment. We are not going to collect anything that is sensitive or that environment specific to you, such as the IP addresses or the directory structure. This is really just to help us understand what kind of product features, what kind of platform that is most used by our customer, so that we can invest in the future, we can enhance our product offering in those specific areas. And not only that, we are also expanding globally. As we are expanding larger scale, we also have diversified into various countries, and we are happy to announce that we localize to these 5 top languages that we see our View deployment is most popular. And we do have localized client in the past, but this is actually the admin UI that's being completely localized, and it is globalized as well. That helps the administrator to manage the View deployment. And we also introduced a couple of features that's also important to the administrator. For example, as we are expanding globally, expanding the scale, we are also seeing customer feeling the need to move the physical machine to the virtual machine, P to V movement, and also migrating from XP to Windows 7. Since last year, we see the uptick to VDI, a lot of them driven by the needs to expand from XP to Windows 7, to migrate from XP to Windows 7. We already have a persona management tool to help manage the persona amount of virtual machines. Now we expanded it so that you can use it as a migration tool to help the migration. With all that, we also take security very seriously. That's why we are starting to offer features that help customer deploy VDI, use VDI in a highly secure environment. Because one of the appeal of VDI is security. You consolidated your desktop, your compute environment into a server-based environment, into a centralized data center so that you can easily manage it. So one of these environments is, say, if you have a very restrictive environment in which the Active Directory does not allow write access from any other program except for maybe from the specific admin using specific tool, then this allows us to actually coexist, to allow us to provision machine using existing machine accounts. And the configuration is quite easy, assuming that you created all those machine accounts ahead of time using the naming patterns or the semi-automatic naming patterns convention. With that, you can easily this is a quick screenshot showing you how it's done. You just enable it as you're creating the pool, as part of the pool wizard. And security also means you can have a freedom of choice to choose the tool that suits your environment or regulation mandated you use. And we provide you such a choice for the two-factor authentication mechanism. We implemented a Radius standard client in the View server so that you can coexist with any Radius compliant servers out there. The names you see up there is for the reference only. And if you have a vendor that's not, the name of which does not show up in the list, or if you're a vendor yourself who can provide two-factor authentication support through Radius, you're more than welcome to contact us or work with your customer to just test it out, because Radius is standard, and we are very confident that it will just work. So with all those, it may sound like a grab bag of all the features, but that's, administration is about all the mundane tasks being able to easily manage using one pane of glass. So that's why, for the Radius authentication, it's just a simple addition of choice when you configure your pool. And you can point it to your server, configure a couple of the server options, then there you go. You just connect with the Radius server. And with that, with the admin side of things addressed, we would now move on to take a quick look at the two, I think, the most significant features in View 5.1 that address enhanced user experience even further on top of the great progress we make in 5.0. And one of such is USB, the new USB architecture. And as you will know, there's a lot of new devices coming up, and they probably come up, every second. And actually, this graphic shows how quickly the market has moved. I get criticized, as I finalize the deck and say, hey, those devices are pretty old already. And that's why we re-architect our USB redirection support so that we implemented a USB arbitrator on the client side and a proper USB agent side on the GETs inside the VM, so that we can easily adopt to a broader selection of devices. For one example, we used to have trouble with iPhone sync, yep. And now we have field reports saying that iPhone works beautifully. You can just connect, and you can just sync with your remote iTunes. And some customer has a closed environment, so we separate out the client release trains from a release perspective. But our admins come back and tell us that, what if my client or my thin clients or my user population, they use it internally inside a firewall. They don't necessarily have to go on the internet to download their client. Or I want to control the distribution of client. So we turn the View connection server into also a portal for your client. So you can have a portal page, completely brandable, completely customizable from the View connection server. Then you can use it as a mechanism for your end user to download the client. So if you have an end user that does not have any local install of the View client, all he has to do is to open up a browser, point it to the View connection server URL, which you are going to give it to the end user anyway. And without a client, it will be redirected to this page where you can distribute any real client that you would like to distribute. So with that, I would like to conclude with a glance of all the features. You will see a glaring hole in there. The View Storage Accelerator is not being mentioned. That's intentional because I want to hand it off to my colleagues here in Arizona to walk you through the entire landscape, what's new and what's next in the storage and the CapEx side.
Thank you, Lebin. So quick show of hands, how many of you are actively using View today? Okay, good. How many of you are adopting over 1,000 desktops? Okay, great. How many of you plan to adopt View in the future, near future? Okay, good. So one of the concerns that we have had from our customer base and analysts agree is that storage is a big portion of the acquisition costs with View today. So we want to look at some of the challenges that storage imposes, traditional storage architectures impose, and how View itself has solutions to address some of the problems and give you an overview of what's coming next. So with that, I will start the presentation and show you what the challenges are. There are two top challenges. One is it's a sizing problem, and the sizing problem is imposed by the traditional storage architecture. Spinning drives usually are IOPS constrained. And VDI has some stringent performance requirements because it's write intensive. The workload is write intensive, and you have highly correlated events like boot storms, login storms, and antivirus storms in your VDI deployment. So those are the challenges that are imposed on the VDI environment, and they cause fundamental problems in architecting your storage system, traditional storage system that are disk-based. And if you get the design wrong and the sizing wrong, you will have an effect on your end user population. Your end users are going to experience a bad response from the VDI setup. And all of this is intertwined to cost. So if you size for large number of users, your cost will be very high. However, you want to get a good balance between cost and performance. You need to have a good price-performance ratio when you are architecting the storage system. And sizing for peak becomes very cost prohibitive. That's kind of, if you size for boot events take about 100 to 150 IOPS. And you would, if you look at 1,000 desktop deployment, you're talking about 1,000 times 150, which is the concurrency rate. You would have about 15,000 to 150,000 IOPS that would be generated on the storage system. So you need to kind of remediate that problem and architect your storage system in a way that optimizes costs as well as delivers a superior end user experience. Because the status quo is the end users are accustomed to doing things in the physical environment where they have a dedicated disk drive. So you want to enable them to go to a virtual environment and at least preserve the user experience. And towards this end, we have some features that we have introduced. We will talk about that, and we'll also outline what our future architecture may look like. So little bit elaboration on the workload variance. So if you look at this chart, the workload for a VDI environment looks like this. If you had, for example, 1,000 users, you would have storm events on the left and right side of the chart, and you would have steady state events. If you size for steady state, your cost will be lower. However, you want to accommodate these storm events. So you want to find a balance between sizing for steady state as well as sizing for peak events. And if you size for peak events, then you're going to satisfy everybody. However, your costs are going to be high. So the cost threshold is kind of shown by the blue line and the red line. The higher up you go and you want to deliver a good end user experience, your costs are going to be really high. So let's play this game. How many of you have had storage sizing problems when you first deployed your VDI deployment? Okay. Quite a few. Okay, so the storage sizing causes a conundrum for architects. So you're unsure how much to buy. On one end of the spectrum, let's play this game. So this is the storage guessing game. On one end of the spectrum, you buy too much because you're unsure how many users are there, you're unsure of the ramp rate, you probably overestimated the ramp rate, and you bought capacity instead of IOPS. Storage sizing for VDI deployments is a performance problem. It's an IOPS problem. And traditional shared storage disk subsystems handle read IOs very well because most of the server workloads are read skewed. They are about 70% read and 30% write. Whereas VDI, because of its concurrency levels with multiple users all accessing the desktop deployment at once and doing operations at the same time, impose undue duress on traditional shared storage subsystems. If you did not have an SSD and you had traditional spinning drives, which are about 15K RPM, you would have a problem because you need to buy more drives just to satisfy the performance requirements. So you spend on space, however, that's how you get IOPS from the storage subsystem. And on the other end of the spectrum, you have too little provisioning of storage because you don't know how fast your user base is going to grow. You're not sure of what the ramp time is going to be, and you do not understand what the IOPS per user is going to be. Some of the common things that we have seen from our customer base is they misunderstand the IOPS that the user could generate, each user could generate, and they end up provisioning a lot less than what would be required from the storage subsystem. So these are kind of the problems that you would encounter when you start sizing for VDI deployments. And the result here is a declining end-user experience. As you start your deployment with 100 users, the end-user experience is great. Probably you started to provision for 1,000 desktops, and you loaded up with 100 desktops, and everybody is looking great. But as you ramp up the deployment from 100 to 1,000 and beyond, the user experience starts declining if you do not really go in the direction of purchasing more storage and deploying, making adjustments to your system. You would have end-user experience that is declining, and the available IOPS per user declines as well. So you can see in this chart that the IOPS available per user is declining as the user base is going up. So one of the things that we have done with View 5.1 is to allow you to size for steady-state events. So View Storage Accelerator was introduced in 5.1. At a very high level, what is this View Storage Accelerator? We rely on vSphere 5.0 technology. It's a content-based read cache in ESX server. You can set aside anywhere between a 100 meg and a 2 gig of memory. And what it does is when you're booting or logging on multiple users, the common blocks that are common to the OS are cached within memory, and all users are serviced directly from memory. You don't have to go to the disk subsystem to read these common blocks. Once they are read and cached in memory, they will be serviced through memory. So memory is a high IOPS device in your ESX server. So you leverage a small portion of ESX memory and deliver high performance benefits to end users. So they will have a consistent boot time. The boot time is very fast for all these users by doing this. And it's 100% transparent to the guest. The guest does not know this is happening. You just have to set aside this cache in main memory on the ESX server. And it's applicable to all types of desktops. You have persistent types and non-persistent type of desktops, and it's applicable to all of them. And you do not need any special third-party array technology. It coexists with array technologies. If you had a read cache on your storage array, it would be cached there, and it would be cached in main memory, so you can leverage your array technology as well. And the benefit that this delivers is one of storage cost reduction. So I go back to the chart that we projected a while back. So the peak events, now the peak events are addressed with this. The read peak events, in particular, the read peak events are addressed with this functionality. And we handle the worst case peak usage through this cache. Let's look at a little bit more deeper on how to enable this caching technology. So we have the notion of desktop pools in VMware View. At pool creation time, you can enable host caching. You can do so for two types of disks, both for operating system disks as well as user disks. If users have a lot of common data, we can cache that as well. So like applications, let's say your VDI deployment has 1,000 users, 500 of them are using Microsoft Word, and one of them starts up Word, the blocks corresponding to Word will be cached in main memory, and you don't have to go to disk to do the I/O operations for that particular application. So that's the benefit that you get in the user disk use case. In the OS disk, we introduced replica tiering with View 4.5. We provided the mechanism to put the master image on a separate tiered device, which was highly IOPS intensive. So you could put your master image on an SSD. Now you don't have to do that. You can cache the master image in memory because the master image has common blocks that is shared by all users. So this is much more performance efficient than replica tiering. However, if you had replica tiering, this is additive to performance. So that's the benefit this delivers. From a little bit detailed deep dive perspective, what this is doing is creating digest files on disk, and it's managing the content-based read cache in memory. That's what it is doing when you set this up. And the cache gets invalidated once write operations happen to those common blocks that are cached in memory. So the digest needs to be recreated on disk. So there is a correlation between the cache that's in memory and digest that's on disk. So you will have to periodically regenerate this cache if you had many blocks change on you. So that's why we have provided a policy-driven engine that would enable you to regenerate the cache subject to blackout times. So the regeneration operation is a little bit intensive, so we want you to schedule it during times of low peak activity. So when your user base is not doing anything and you do not have active IOs going on your storage subsystem, we want you to schedule this operation, and the way you would go about doing it is by defining a blackout window. So in this example, we have defined a blackout window between 8 a.m. and 6 p.m. That's when usually organizations are very active with their user base. So we have defined that to show an example. So between 6 p.m. and 8 a.m. is when the regeneration happens. And it's highly dependent on the use case based on how many blocks change. So if you are just doing it for OS disks, the disk blocks will not have changed that much unless you have done an update to the OS disk. That's kind of how this works. And we have some results. We did internal tests. We set up our own product, and it's VMware on VMware. So we did some tests internally, and we measured some of the performance benefits that this can provide. So from an IOPS perspective, we had a shared storage system. To give you a little bit more color on the environment, we had a shared storage system backing a cluster of virtual desktops, and we measured the IOPS that were generated to the storage system during a bootstorm type event. And we saw about a 80% reduction in the peak IOPS as well as a 45% reduction in average IOPS. So you can now correlate this to the cost picture, which is you don't need to provision for peak events. A small portion of ESX memory will get you the IOPS that you need during these peak events. That's kind of how it is, and you don't have to size for peak workloads anymore. You can size for steady-state workloads. We also extended the test a little bit and looked at the network bandwidth connection. So this is the switch that sits in between the ESX cluster and the storage system, and we saw how many bytes of bandwidth we could save and how many were really consumed. So we saw about a 45% reduction in peak bandwidth. What does this mean? This means that you can now have a lower bandwidth switch sit in between the storage system and the ESX cluster. So you will save a bunch on CapEx costs there by just leveraging this technology, which is just about a gig or 2 gig of memory in your ESX server. That's the power of the View Storage Accelerator. And we extended the test. That was a single host bootstorm simulation that we did with our own setup. And we extended the test to look at a multiple host bootstorm case. Similar setup. We had a shared storage array at the back end. ESX servers all loaded up based on the consolidation ratios that we have. We saw about a 65% reduction in peak IOPS and about a 35% reduction in peak bandwidth. So the takeaway here is a small portion of ESX memory will reduce the bandwidth generated on the network switch as well as reduce the IOPS generated against the storage system, shared storage system, traditional shared storage system. So you can provision less, accommodate your peaks through this technology. That's the power that View Storage Accelerator brings to the table. Moving on to the next feature, sure.
Why there's a 2 gig?
So the question was, why is there a 2 gig limit? So for most OS-intensive operations, we have seen that 2 gig is more than sufficient to address the read operations. Beyond 2 gig, we do not see any benefits. So 2 gig, so for a typical bootstorm operation, we have seen that 2 gig is the space that gets addressed during a boot or a login operation within the Windows operating system. So that's the reason why we have that. Another question there?
Does this work on just VMFS or NFS volume as well?
It works on both VMFS as well as NFS. So it's much more removed from the storage subsystem. It's an ESX-specific technology. It is on the memory on ESX. We have another question? So the question is whether this works for both persistent and non-persistent desktops. Yes, the answer is it works for both full clone as well as linked clone type desktops, both View Composer and non-View Composer. Mm-hmm. Yes. Yes, it is.
The second is created, or does it have to do this indexing?
So there is a setup phase. So the first desktop will take quite a bit of time. And there is a setup phase that generates the digest. So, the first desktop will take time, but the desktops after that would boot pretty quickly because the cache is warmed up.
So if you create 100 VMs, then you won't get the bootstrap reduction the first round?
You do get it in the first round. It's just for the first desktop that boots in that 100, you would see the cache being warmed up. Yes. I didn't follow. No, we did not. We have just done with a traditional storage system because most of our customers are having traditional storage systems at the back end. So we have done that simulation. Sunil can probably confirm that. Yeah. Sure. The benefits should be additive. It depends on whether you use SSD or local spinning disk. I think we can take that conversation offline, but definitely you will see benefits even at that scale. And 1 gig to 2 gig is a small price to pay given the performance benefits that you derive using this feature.
Quick question. You guys mostly write I/O, read I/O?
Yes.
So is this optimizing the surface with a small amount of read I/O, or is this layout the write I/O?
So this is only read I/O. We will talk about write I/O. So when I get through my presentation, I will address the issue of write I/O and give you a couple of ideas on where we are headed and give you an architectural overview of how the write I/O problem could be solved. Okay. Any further questions? Okay. We'll go as we'll run through the slide deck and we'll do a detailed Q&A at the end.
We will take
hopefully
Q&A at the end as well.
So the next feature is for those customers who have a NAS-based storage system. We tech previewed this feature called View Composer API for array integration. So at a high level, if you had a NAS storage system and it's VAI NAS capable, so we have a set of VAI NAS primitives that are enabled through ESX, you can now offload the cloning operation to the storage array. So the View Composer linked clones have the concept of a redo log. So the redo log portion of the clone is offloaded to the storage array. So it becomes a native snapshot on the storage system, and it's not a snapshot or clone that is done by View itself. So we are offloading this. The benefits here are you are saving a bunch of CPU bandwidth because the ESX server is not doing the cloning operation. It's offloading to the storage array, and the storage array CPU is actually doing the cloning operation. The other benefit that you have is traditionally with prior versions of Windows, like Windows XP, prior to Windows 7, you had the alignment issue. Since the storage array manages the clone, you don't have the 4K alignment issue anymore. So this feature primarily benefits those customers that have invested in NAS storage systems and they are using View deployment. So it's kind of leveraging both the features together. So you get the best of View Composer image management as well as the storage optimization that View Composer brings in terms of reduced capacity on the clone, as well as gives you the benefit that the storage system gives you because they are very good at managing snapshots and clones underneath using their storage technology. So that's the feature that we brought to market. It's tech preview. We are working with our storage partners to do a certification program. It's going to be an extension of the VAI NAS certification program. Once we have a couple of partners certified, we will support this feature. We'll officially support this feature. So it's a tech preview feature at this point in time. And the benefits are performance benefits because you offload, speed of provisioning, because you offload. So those are kind of the performance benefits that you have. So it protects your investment in NAS storage systems. So that was what we introduced in View 5.1. Those were the two main features that addressed some of the storage challenges with View 5.1. View next is going to raise the bar. So this is the next few releases of View that we are talking about here. And one of the things that we will be introducing is space-efficient virtual disks. As you probably saw this morning's keynote, we announced the availability of vSphere 5.1. vSphere 5.1 has the notion of space-efficient virtual disks. And to give you a little bit background, when you create a linked clone in a View Composer type environment, there is the notion of a redo log. The redo logs have 512-byte granularity, and you can grow. There is a famous adage by Sunil which says you can grow the redo log at any time. Redo logs are beneficial, but you can grow them, you cannot shrink them. So what does this mean? So typically, you have a Windows guest operating system. There is an NTFS volume that the Windows operating system is managing, and you have about 1 gig of use space. And there is a corresponding redo log for this guest operating system. It's about 10 megabytes. Now, the users will install or copy some new files to their guest image. And you can see that the NTFS grows by about 200 meg. Let's say this was 200 meg of an application, and they copied a few files. You see that the NTFS grew by 1.2 gig, and correspondingly, you see that the redo log grew by another 200 meg. Now, if they uninstall the application or delete files, how much would you expect the redo log to be? What's the size of the redo log? Any guesses? OK, I heard 1.2, but I was just talking about the redo log, not the guest disk itself. No, it remains at 210 meg. So when you deleted 200 meg, you are not able to reclaim that 200 meg in the redo log-based clone. So with this new feature, we provide the option of reclaiming that 200 meg, close to that 200 meg of space. So you can grow these redo logs. The way customers are addressing this issue is to do a View Composer-based refresh operation, and some of the customers do a recompose operation. They merge it along with the image management capability that View provides. However, this feature will eliminate the need to do a refresh or a recompose to reclaim that space. It's a completely new format that we have introduced. It's a new VMDK format for all the VMs. And you end up paying for space that users use. You do not pay for space that users do not use. Like the deleted files is unused space that gets left behind on the traditional storage system. So you would be now able to reclaim that space. And the way we do the reclaim is through two operations. There is a wipe operation which walks through the VMDK in the VMFS, tags all the unused extents but allocated extents, and there is a shrink operation which actually reclaims all the space. And it solves the Windows XP type 4K alignment issue. So you do not have that alignment issue. There is guaranteed 4K alignment. So the key takeaway here is for those customers who are doing full clones today, they can now go to a storage capacity optimized linked clone and provide the full clone type benefits to their users. So that's the equivalence that we get with a composer-based linked clone. So with full clones, many customers use full clones as well as SCCM to do image management. Now you can use link clones and use View Composer for image management purposes. That's kind of the power of this feature that we get. Sure, there's a question? Yes, it's part of the tools. It's part of the guest tools. That's how it does the wipe and shrink operations. And again, the current thinking is to drive this through the same policy-based engine that View Storage Accelerator has. That's kind of the current thinking on that. But yes, there is a guest tools that does the wipe and shrink, which does the unmap to the storage system. The question is, does it increase the I/O load on the storage system? Again, as we alluded before, it's subject to blackout windows, so you want to schedule it when there is low levels of activity. It would incur some I/Os, and it's a function of how the unmap routine is implemented within the traditional storage architecture. So it's a function of the storage array as well as a function of the guest tools that generate that. So that's why we have given you, we plan to give you the levers that would control when the unmap runs on the storage system. So with that, that's kind of what is coming. So the key takeaway there is you're going to get a capacity-optimized footprint for your View deployment. So you are going to consume less storage from a capacity standpoint. So we are doing things to address the cost problem with capacity. So you have to store less for these link clone type deployments and get full clone equivalency. So with that, I will switch gears a little bit and look at how storage architectures are changing in the marketplace and what is the future for View from a storage perspective. How many of you have here attended Steve Harrod's keynote today? Okay, quite a few. So as you probably saw, Steve talked about the software-defined storage in the data center and a software-defined data center, and he announced virtual flash and virtual SAN type technologies. These are the two technologies that will be the focus from this point forward in the presentation, where we will see how it fits in a View type of deployment, VDI, how View can benefit from this type of technologies. So before we look at that, the storage architectures are changing in the marketplace today. You have direct attached storage, you have scale-out storage, you have blob storage, and you have traditional storage architectures such as the enterprise, SAN, and NAS. All this is happening because new applications are coming to market that have varied requirements from the storage subsystem. And there is also a new penetration of technologies such as SSDs and Flash. We will talk about those a little bit later. And these are driven by market trends. So if you look at the server itself, the number of cores available on the CPU is increasing. I think we are going to get to about 32 cores pretty soon, 16 to 32, and then probably to 64. And hard disks are also increasing in the density that they support. If you look at a 15K RPM drive, we were at about 300 gig. A couple of years back, we'll be at 900 gig and soon be at 1.2 terabytes for performance drives. And then Flash is becoming more and more prevalent in the marketplace. So all of this, the CPU compute power, the amount of storage available, all of this is generating a lot of data. Combined with the new applications such as Gemfire, Hadoop, big data type applications, VDI, all of this is generating a lot of data. And the end result, you can see that some analysts have forecasted that about 800 exabytes of data will be created in 2015 timeframe. And the final aspect is Flash is gaining prominence in the data center. There is server-based Flash, both PCIe as well as SSD-based Flash that's there in the ESX servers, as well as general-purpose second-tier cache supplementing the array cache. So there is arrays have SSDs which are acting as cache. There are some storage technologies out there that support it as a cache as well as persistent storage. So the key takeaway here is you can set aside a portion of Flash and use it as cache for your workloads. And that's kind of the trend that is evolving in the marketplace. And then use 7.2K RPM SATA drives to support your density requirements, or even 15K RPM drives to support your density requirements. And there is a Flash ratio that you use for your disk ratio, it's about less than 10% today, and that's how storage systems are architected. Both these trends, the direct attached storage as well as flash storage, have a lot of benefits for the VDI use case. So if you look at flash-based, pure flash-based storage, it addresses the IOPS requirements for VDI. So in today's announcement, we saw that there is a technology called Virtual Flash. It's a tech preview. We'll be tech previewing it during this VMworld. I'll give you a pointer to the other session that you can have a deep dive on. We are tech previewing this technology. So there is a flash infrastructure layer which aggregates and pools all the flash that's available on the ESX cluster. And there is a caching software layer that exposes a cache to the VM. We'll do a deep dive on that. And server-based distributed storage addresses the capacity requirements as well as performance requirements for VDI deployments. We'll talk about that as well. So let's do a little bit more deep dive into SSD-based caching for these virtual machines. So at the very fundamental level, you have the flash infrastructure, which aggregates SSD as well as PCIe-based flash into a common resource pool. On top of it, there is the caching software tier, which allows you to set aside a portion of this infrastructure for individual VMs. It's similar to a resource such as CPU or memory that you allocate for your VM. So a typical VDI situation could be that you set aside a 2 gig flash for each VM or master VM, and everybody else inherits that 2 gig flash. It's both a read and a write cache. And there are parts of supporting it in 2 write modes, a write-through mode, which does read caching as well, and a write-back mode. The write-back mode will commit the I/O to flash and destage it back to disk. That's what the write-back mode is. So the IOP latency is tremendously reduced because of this technology. So in VDI deployments, you have this write I/O acceleration, which tremendously gives you the IOPS density as well as the IOPS latency and gives you superior user experience. In addition to this, if you used content-based read caching or the View Storage Accelerator, your boot times would be significantly improved, as well as the steady-state times would be significantly improved using this technology. Our partner ecosystem can write plugins. It's completely API-enabled. This technology will be completely API-enabled and exposed to partners. They can add value on top of this technology as well. So the key takeaway here is it provides I/O acceleration for VDI deployments, both read as well as write caching. And it's performance additive with the use of View Storage Accelerator. That's kind of, in a brief summary, what Virtual Flash does. So it allows you to pool all the flash infrastructure as well as allows you to provision flash as a cache for the VM. Let's switch gears a little bit and talk about distributed storage, VMware distributed storage. So you first start with the VDI virtual machines. Then you have the ESX cluster, where all the virtual machines reside. Then you have your vSphere layer. Then you'll have this new layer, which is the distributed storage layer. It's completely built into the kernel modules. This distributed storage layer will aggregate the local SSDs and local hard disks on the ESX servers and aggregate them and expose them as a data store. So you would get a complete data store exposed to you from direct attached storage. And each VM has a VMDK that is mapped on this direct attached storage data store, distributed aggregated data store that this distributed storage software provides. And an I/O, either a read or a write, goes to the SSD tier first and then goes to the disk tier. So this is the technology that would enable you to do both persistent, non-persistent deployments, as well as get you high IOPS and low latency IOPS. I have a question there.
Is this built into View or is it part of the storage line?
It will be built into the vSphere kernel. It's a tech preview technology at this point in time. It will be baked into the kernel. There is no appliance that is required. There is no VM that is doing this. It is part of the vSphere kernel. So View sits on top of this technology, and you could get a very good price performance from this technology because it's local flash and local drives. You could get a very good price performance. Everything is local. So that's kind of what this technology does. So let's look at this. So this exposes one data store per cluster. It's a SSD is a caching tier. It's both a read and write caching tier. We talked about write caching and two modes of write caching, write back and write through. This is going to be write back mode, where the application will write to SSD first and be acknowledged by SSD because it's a very low latency I/O operation. And the D stage happens at the back end where it gets committed to multiple nodes. So there is a replication commit at the back end. You will have a 10 gig Ethernet switch. You would require a 10 gig Ethernet switch for the replication to happen. That's kind of the current thinking. And spinning disks will have the persistent storage for this. So in a VDI type deployment, you get both read caching, write caching benefits, read caching with content-based read cache or view storage accelerator, write caching with this technology baked in, as well as the persistence for data that is required at the back end using spinning disk drives. That's what we do. And lower TCO because everything is local, good price performance from this technology, everything is local, and it would be a tightly integrated solution from VMware, VDI, and vSphere integrated. And end user experience, finally, end user experience would be great because everything is happening in the flash. You would barely be going to the disk to do anything. You would be serviced from the flash. And with that, I want to conclude with some of the key takeaways with what we discussed here. View 5.1 has many features that improve both end-user experience as well as reduce TCO. We saw that from the View Storage Accelerator as well as View Composer API for array integration. View Storage Accelerator in particular handles the peak events and reduces the amount of storage. You don't have to size for peak events anymore. And space-efficient virtual disks provide you optimized capacity. So you get the full clone equivalence at a link clone type footprint, storage footprint. Virtual flash and virtual VMware distributed storage will provide you I/O acceleration capabilities for both read and write type workloads that happen in VDI deployments. And with that, we have some giveaways here. We have a new website that compares us to the competition and why you should choose View. Take a look at this website. We recently launched this website. And finally, the related sessions, I would highly encourage you to go to the VMware Distributed Storage Tech Preview session, as well as the Virtual Flash Tech Preview session, which will have a lot more deep dive on those two particular technologies. Thanks. And we are open to taking questions now.
And there's a microphone in the back.
Yeah, there's a microphone in the back.
Thank you.